All right, the second part of the lesson today is on an ellipse. An ellipse is an oval. Remember, it's a conic section. It's part of a cone. It's formed by cutting out a slice of a cone that's not parallel to the base. Now, what happens is it's formed from these two focus points. And I have I have a video. It's not short enough for me. But I'm going to kind of fast forward through it here. I just want you to see, because normally I would go to the board and do this. See, what happens is if you take a string and you attach it at these two focal points and you draw, let me turn off this volume here, and you take the string, put your pencil or your whiteboard marker, and then he moves the pins closer together, okay? And he's going to get a different ellipse. Now, the line through the two pins is called the major axis, okay? And the total length of the string is actually the length of that major axis. So if we were to stop it right there, see, the string goes from here to here, and then this little extra piece of string where it's doubled up would be this piece over here. Okay? Now let me see if I jump ahead if he draws this one more time. He moves them in closer, I think, again. Okay? And anybody know what would happen if he moved them really close together? Let's see if I can play this here and just... The closer they get together, the closer it gets to being a perfect circle. If you put them right on top of each other, then you'd have a circle. Okay? So I'm going to stop this and go back, whoa, just kidding, to this and talk through this. All right, so normally when I start ellipses, I go to the board, I tape down a piece of string, I draw an ellipse, and we talk about how it's related to a circle. When you take the two pieces, the two ends of the string, and you put them on top of each other, so your string goes like this, then as you took your pencil and stuck it in here, it would make a circle. But as if you take the two ends of the string and you tape them down here, and you put your pencil in, it will make this oval. Now, what is staying the same is the length of the string. If you moved those 2 points up and down from each other instead of across from each other, then the oval would go this way. Okay? All right, so it's called an ellipse, and what's important is these focal points, and that's how you draw the ellipse. Okay? I'm not going to talk about this particular... You have this on a reference sheet. This is how to find all of these things from this picture. Okay? And I will talk about this eventually. The thing you need to know is that for an ellipse, the A represents the bigger number. So when the bigger number is underneath the X, it's longer in the X direction. And when the bigger number is underneath the Y, it's longer in the Y direction. These are examples of ellipses that I found on the internet. This sounds really weird, but when you have an elliptical room, the focal points of the room are what make it into like a whispering chamber. Has anybody ever been somewhere where you could stand, like, here's a focal point, and at the other end of the room down here's a focal point, and if you stand down here and whisper, this person here can hear you really clearly, and no one else in the room can hear as clearly. It's because the sound bounces off from one focal point to the other and bounces here. Okay, the Earth's orbit is an ellipse. You've heard all these kind of things. All right, I'm going to keep moving here. An ellipse is a locus of points such that the sum of the distances from any point on an ellipse to two fixed points remains constant. That's the string, okay? When you have a focus point and a focus point here, the thing that's staying the same is the length of the string. These two fixed points are called the foci, and that's just the plural. Okay, focus and focus. And what it wants you to write here is D1 plus D2 remains constant. It's the length of the string. Okay. The major axis is from the center. It's from one vertex to the other. It's the longer, okay? It's the length of the whole axis that runs through the focus. I don't remember what I put for this blank. Let me double check. It says longer axis of symmetry. And it goes vertex to vertex. And by the way, that makes it 2A. All right, then we talk about the Khan Academy stuff does radius, and the radius would go from the center out to the vertex. So it's the length of A from the formula, and it's from the center to a vertex. All right. Now, the other guys that aren't called the vertices are called the co-vertices. Okay, they are the shorter direction here. So that's the minor axis. It's the shorter axis of symmetry. And it goes from co-vertex to co-vertex. And so the minor radius is the B value from the equation, or it's from the center to the vertex. Co-vertex, sorry. So the minor axis is the length, complete length is 2B. All right, let's see, new color here. The center is just the point here in the middle where those the axes intersect. I don't think you need a whole bunch of explanation. It says, I just wrote HK because I'm too lazy to write about. It's where the two axes of symmetry intersect, but that's a lot of writing. Okay, the foci or focal points are always on the major axis. Okay, and the distance out from the center is C. And we're going to talk about how to find C in a minute. All right, the vertices are at the ends of the major axis. And the co-vertices are at the ends of the minor axis. All right. So, what did I just do? What just happened? Okay. So here again is a picture, and it's relating it to this equation. So let me go over this, because I think it's important you understand the concepts, not just that you can use the reference sheet. So from the center, you go out the longer distance A, or if it's a vertical one, you go up the longer distance A and down. Okay, that's the vertices. Whatever the smaller B value is here, if it's shorter across, then this one is B, and you go out from the center B. If it's up and down, the smaller B is under the Y, and you go up and down that much. That's it. This is the formula, guys. It's like a circle, but it's been stretched in one direction A, and another direction only B. They're not the same. And you always have to make it equal to 1 here. Okay, now we're not going to do any craziness this year. In a normal year, we do finding the equations with where you have to complete the square twice and figure out the stretches and all that. We're just going to do the basics this year. This is like Hofbauer's favorite topic, and I'm really sad that we can't spend 2 weeks on it, but we're not going to. Okay. The The formula to find C is not the Pythagorean theorem, okay? It gets a little confusing later because when we do hyperbolas, it is the Pythagorean theorem. But because the focus is inside, you have to take the longer a squared minus the shorter b squared, and that'll tell you C, the distance out to the focus point. And we're not going to do eccentricity at all this year either. So we get to skip that idea. Eccentricity has to do with how stretched it is. All right. So when you have a horizontal ellipse longer this way, the co-vertices are A, doesn't matter which way it's going, okay? The vertices are A units away from the center, and the co-vertices are B units away from the center. So on this one, A is here. On this one, A is here. And B is the shorter way, so B or B here. And the length of the major axis is 2A. The length of the minor axis is 2B. The foci are C units away from the center. And to find C, you do C squared equals A squared minus B squared. And so C is from the center out to this focus point is C, or on this one, it's here. All right, I hope you're getting the ideas. So when you go to graph these, you're going to write it in this form if it isn't already, and I'm only going to do them in this form this year, so is Khan Academy. You're going to find the center HK. This one has no shift, so the center is at 0, 0. There's no X plus or minus or Y plus or minus anything up top. You're going to graph the vertices by dividing the larger denominator, square rooting. Remember, this is A squared. So A is 8, and it's under the X. So from the center, I'm going to go 8 this way and 8 this way. So the vertices are going to be at 8, 0 or negative 8, 0. Or the fancy formula from the reference sheet is, let's see, that would be H plus or minus A, comma, K for the vertices when it's going horizontally. All right, because here, H and K were both 0, and A was 8. So 0 plus 8, 0 minus 8, and K was 0. All right. The co-vertices, I'll just use red still. B squared is 25, so B is 5. So we're going to go 5 up and 5 down. And so the formula for those is H comma K plus or minus B, and that's because it's not the same if it's going the other direction, but we're adding on to the Y because that's the one it's underneath here. So we get 0, 5, and 0, negative 5. All right, so now we can draw the thing, actually. And mine always look like an egg or something. And then we have to find the focal point, because that's the other thing you have to label. The focus point is on the major axis. So in this particular problem, it's on the x-axis. And to find C, remember C squared equals A squared minus B squared. Well, A was 8, so A squared was 64. B was 5, so B squared was 25. If you subtract those, you get what? 39. So the square root of 39 is how far they are out from the center, or let's go with a decimal so that we can graph this. 6.2. So if we go 1, 2, 3, 4, 5, 6, and a little more, That's a focal point, and this way the same thing. I think it's in there as a focal point. Okay. Now, when you do this in Khan Academy, it will ask you how long is the major radius on this, which is just A. Okay, the major radius was 8, and the minor radius going this way was 5. Just so you're aware, it's going to ask that question. All right. Ooh, this one is a little trickier because the center is not at 0. I feel like there's another one with center at 0. Is there on your notes? Did I not fix this slide? Hang on, I gotta double check. All right, on the notes, I think I give you 2 easy ones. Or on the practice, I mean. I don't even know if you have practice on this. It's all on Khan Academy. Anyway, all right. This time, let me write underneath here. We have x minus h squared plus y minus k squared equals 1. But remember, the bigger one is the a. So the a squared is under the y. The smaller one is the b. The b squared is underneath the x. So h is 5. K is -2 because it's the opposite of this. So the center, if you look on this reference sheet, it says the center is always at HK for either one. Okay, just follow the recipes right on here if you're not good with the concepts. So the center is at 5, -2. All right, then b squared is 9, so b is 3. So we go out 3 each way in the x direction. Now that's the smaller one, so that's going to be the co-vertices. So that's going to be 5 plus 3 and 5 minus 3. Because it's in the shorter direction, so we get 8, -2, and 2, -2. All right, now the longer direction is in the y direction. So underneath this, a squared is 36, so a is 6, and that's in the y direction, so we go plus or minus 6 back here. So we get 5, -2 plus 6 is 4, and 5, -2 minus 6 is -8. Or, conceptually, you just go over here, you find 5, -2. Did I count too many? 1, 2, 3, 4, 5. Nope. Okay. And then from there, you look up here and you go, in the y, I'm supposed to go 6. In the x, I'm supposed to go the square root of 9, which is 3. And I'm done. It's longer up and down than it is around. Except I have to find the foci. That's the tricky part, okay? And the foci, you need c. And remember, a squared was 36. B squared was 9. We're supposed to subtract, and that'll give us c squared. Well, 36 minus 9 is what? 17, 27? Okay. So c is the square root of 27, which is 3 square roots of 3, but a decimal is fine for purposes here. So the square root of 27 is 5.2. And they're on the major axis, so it's going to go up from here, 5.2, way up top, and down 5.2. I will tell you, the further out, the closer to the edges that it is, the narrower it will be, okay? The further in towards the middle that the foci are, that will make it more circular. All right. So the foci were up and down. So they were at 5, -2 plus or minus 5.2. As we added and subtracted them on the y value. So that would be 5, 3.2. Does that look right? 1, 2, 3. And 5, -7.2 down here. Okay. I don't think it asks you for the ordered pairs in Khan Academy for the foci. All right. Major radius was in this case up and down. So it's really just asking you what A is. And minor radius was across, which was 3. Radius, remember, again, goes from the center only one way, not major axis would be 12 and minor axis would be 6, all the way across. Okay. So I'm going to go through this one quickly and then maybe let you do that one on your own. So this one would have H is -4 and K is -1. The X goes with the H and the K goes with the Y, whether they're long ways or short ways, whether it's vertical or horizontal. So the center is at HK or -4, -1. And then A is the bigger number, so A squared is 25, so A is 5, and it was underneath the X, so I go 5 to the left and 5 to the right. And the B squared is 9, so B is 3, and that was underneath the Y, so from the center I go up 3 and down 3. And I draw an oval. All right, so we found the vertices were out 5 in the X direction. So there's a formula for that, but it would be -4 plus or minus 5. So that would be 1, -1, and -9, -1. The co-vertices were up or down 3, so you're putting the 3 back here on the Y. So you'd have -4, 2 when you added 3, and -4, -4 when you went down. The foci, we have to find C now. This is C for center, but we need the foci, which are out on the major axis. So if it's A squared minus B squared equals C squared. I got to scroll back up a little bit here, but it's 25 minus 9 equals C squared. 25 minus 9 is 16. Did I do that right? It's late at night when I'm making this video. Not really. It's 4 in the afternoon, but I'm brain dead. 4 equals C. So I go out 4 this way, 1, 2, 3, 4. Yay, a nice number. 1, 2, 3, 4 this way. Okay, so the foci were from the center 4 units in the X direction, so the plus or minus 4 goes here. What it would say, if you go back to this sheet, it would say when it's longer horizontally here, the foci are at H plus or minus C comma K. When it's longer this way, up and down, then you add the C onto the second or the K value. The little reference sheet will tell you where to put it if you're not just following the concepts here. Is this the one I'm working on? Yeah. So the foci are at -8, -1, and let's see, -4 plus 4 should be 0. All right. So I'm thinking I'm going to skip this one. This one is longer up and down, okay? It looks very narrow. Maybe I'll just fly through the graph and then you could find all the points. Go to the right 5, 2, 3, 4, 5, and up 3. And then in the X direction, you go square root of 4, which would be 2. In the Y direction, you go square root of 49, which would be 7. I think that's the top. Ooh, that one's very narrow. So the foci are going to be really far out to the end. The foci, c squared would be 49 minus 4. So you'd have 45. And the square root of 45 is 6.7. So remember, this was only up 7. So if you went out 6.7, you are way out here. The far reaches. Okay? I'll fill those points in. You guys try to do it on your own and then go back and check my notes. All right, then we're going to practice the other direction, which is writing an equation. So we need here h and k and a and b. We don't even need c. All right, so if we draw these in, the center from the origin right here is left 1 and up 2. So the center is -1, 2. All right, the major axis, the whole thing, is all the way across, which is 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So the major axis is 14 long. The major radius, which we need to put in, is 7. And remember, it's A, because it's going to be the bigger one. And then up and down is 3. So the whole thing is 6. But the minor radius, the B value is 3. So the equation, remember this is H and this is K, so we have X plus 1, Y minus 2, and it always equals 1. And in the X direction, okay, we went 14 either way, so you'd have 14 squared or 196. Nope, just kidding. That's the whole thing is 14. The radius, we went 7 each. Whoa, sorry. Undo. We went 7 each way, so this is 7 squared or 49. Yep, I got confused. We went 3 each way, so this up and down is 9. That's it. They get a little bit trickier, but let's try this one. Oh, tricky. If we know the vertices, where's the center? Well, the center's always at the midpoint. So just like we did with circles earlier today, you're going to have to add and divide by 2. So 5 plus -19 is -14 divided by 2 is -7. And -2 plus -2 is -4 divided by 2 is -2 because they're lined up from each other. So it just stays at -2. All right, so my formula is just x plus 7 quantity squared plus y plus 2 quantity squared equals 1, except the minor axis is 10. So b is half of that, which would be 5. Okay, if I were to sketch this thing, I'd go left 7 and down 2. And then the minor axis is 10 units, so it's 5 up and 5 down. And we got to figure out what the major axis is. How do I know the major axis goes that way? That's a good question. Well, let's see how far apart these bad boys are. From 5, -2, oh, wait a minute. -7, -2, 5, -2 would be over here a lot, right? From -7 all the way to +5 is 12 units over. This is a distance of 12. And then from -7 to -19 would be 12 units to the left. So that's how I know the major axis is going across. Because these points, I should have started by plotting those points, are way far apart going in an X direction or a horizontal direction. So they were 12 units each way, and up and down was 5 units each way. Okay, so the distance from this point to this point was 24 apart, which made A 12. All right, I'm going to do a better job of explaining this one. Co-vertices. Ooh, interesting. All right, so the co-vertices are 9 over and up 1, and negative 3 over and up 1. But remember, that's not the longer one. The longer axis is 28, which means from the center, which we need to find, we go up 14 and down 14. Okay, so that's going to be A is 14. But the co-vertices were from 9 to the right to negative 3 to the left would be a distance of 12. So B is 6 either way. The center is at the midpoint. So 9 plus negative 3 divided by 2 and 1 plus 1 divided by 2, which is 6 divided by 2 is 3. And 2 divided by 2 is 1. So the center is at 3, 1 right here. And we went up 14 and down 14, and we went left 6 and right 6. All right, so we have x minus 3 squared, y minus 1 squared. This is in the 14 is in the y direction, so under here goes 14 squared, which is 196. In the x direction, we went 6 each way, so there's a 36 under here. Okay, those are tricky, but we'll practice some more in a meet. All right, last kind is when they give us a crazy thing like they give us the foci. So these are all centered at the origin, so they're pretty easy. But over 0 and up 12 and over 0 and down 12 are the vertices. So HK is at the center, okay? And if these are vertices, that means A is 12, because we went up and down 12. And the major axis is 24. Major radius is 12, okay. But the foci are out at the square root of 95, which is less than 10. So we have to use that. C is the square root of 95. We have to use that to find B before we can write the equation. All right, the rule is A squared minus B squared equals C squared. So 12 squared minus B squared is the square root of 95 squared, which is 95. So 144 minus 95 equals, if I subtract 95 over to this side and I add B squared over to that side, do I need to show that work just once? If I add B squared over here, you have 144 equals 95 plus B squared, subtract 95. Okay, 144 minus 95, in case I'm brain dead, is 49. So B is 7, but we only need to write the equation, we really only need the B squared anyway. So the center was at the origin. In the x direction, we're going B, which is 7. 49. And in the y direction, because those are the co-vertices, remember? Because the vertices are at the end of the major axis, which was 12 up and down. So this is 144. All right, last one. Do we have 12s again? But this one goes across. Okay, so 12, 0 and negative 12, 0 are the vertices. So that means the center is at 0, 0. The major axis is 24 long. Major radius is 12. A is 12. All right. So somewhere up here is our b values. But the foci, is at the square root of 23, which is less than 5. Negative square root of 23, positive square root of 23. That means this thing is really round. All right. So c is the square root of 23. So a squared would be 144 minus b squared would equal c squared, and that would be 23. So if we add b squared over here and subtract 23 over here, subtract and you get 121 equals b squared, which makes b 11. Remember I told you I thought this was going to be really round? That's because the foci are so close to the middle. So if you go up 11 and down 11, you'd almost get a circle. Ooh. Mine is not a circle because I'm just drawing in the middle of nowhere. So in the x direction, we went 12, so 144. And in the y direction, we went 11, so 121. All right. I hope you got something out of this. I went fast. I realized that. I skipped one. I'll go back and do it. You do it for your notes. And then try all this on Khan Academy. They have videos too if you want to watch them instead of me or if you need more help.